Guess who's back? Stats is back. Let's go. We're trying to estimate the average weight of an Oreo cookie, determine if the average weight is less than advertised. So we have someone who already did this. Ms. Gallus is awesome over at StatsMedic. She got a random sample of 30 cookies, found the weight of each cookie in grams. The mean weight that she got her sample mean, that's at X bar there, was 11.3921, and she got a standard deviation of her sample of 0.0187. And we want to make a 95% confidence interval to estimate the true mean weight. So a little different than the last couple classes where we've talked about true proportion of things. Now we're talking about true mean. So we're going to have a slight change later on, but the overall steps pretty much the same. So we're starting out with our point estimate. That is going to be our sample mean that we took, that Ms. Gallus found for us. So that's going to be X bar is that 11.3921. So remember to put a bar over your X. Remember, you can do that with a shape tool. So we have X bar, that's our sample mean. Our population parameter, sample statistic, our population is going to be all Oreos. And we want to know from that the true mean, mu. So let's get our equation editor and throw a mu in here. Nice and big. We want a mu, looks like a U, with a little front tail. And that is going to represent our true mean weight of an Oreo cookie. Our sample are the 30 randomly selected Oreos that Ms. Gallus found. And our statistic is what we found, our sample mean, which is that X bar up here. We can just copy and paste that down and make sure we also have our bar on top of our X. All right, so that's what we have, what we're looking for. Next, we want to calculate the standard deviation of the sampling distribution. So we're going back to lesson 6.5 here. So let's get our equation editor here. We want to find the standard deviation, a little subscript of our sample mean. We'll throw a bar on that shortly. So we want to find that, and the way we do that is we take the population standard deviation that we have and divide it by the square root of the sample size. However, we don't know the population standard deviation, but instead we do know that we have a sample standard deviation, S sub X, that Ms. Gallus provided for us. So we'll divide that by the square root of the sample size. Let me make sure we can all see that real quick before we continue. Let's make this a lowercase s. There we go. Let's throw a little bar on top of that X down here. And we should be okay to go. So we are told that the sample standard deviation right here is 0.0817. And we divide that by the square root. The square root of our sample size, 30 Oreo cookies. And when we find that, we get 0.0149. So a couple notes here. We're going to jot down the side. We don't know the population standard deviation, so we use the sample standard deviation. That's probably too big, so we can leave that there. That should be fine. And then over here, we can also refer to this as standard error. So we have our standard deviation of the sampling distribution of our sample mean. Number 4 wants to know, was this sample a random sample? And we are told yes. We saw the words random sample early on, and this is important so we can generalize our conclusions to all Oreos, the population. Let's make sure we can read that. So we started checking some conditions, randomness, and then also normal distribution. So last couple classes for proportions, we've been using large counts. We don't have a P here, so we can't use large counts. Instead, we have to make sure that our sample size is large enough. So we're going to use the central limit theorem to make sure that it is large enough. And so we do know that 30 is greater than or equal to 30. So yes, we can, so it is appropriate to use a normal distribution to model according to the central limit theorem, CLT. Our sample size is large enough, just large enough. 30 is greater than or equal to 30. We can, of course, write that as one symbol if we want. I'm probably just going to draw in another line right underneath that. 30 is greater than or equal to 30. So last couple classes, to find the margin of error, we've been using our critical z-score. With means, we cannot do that. Instead, we are going to be using a critical t-score. So t with an asterisk there. So to find it, we actually need table B. So I've linked on Canvas this whole document here. It actually has our table A with our z-scores, which we can use to find our critical z value. And we can scroll down to page 5 here. We see table B is the t distribution of critical values. So it's kind of the same idea. It's the probability to the right of our critical t value there. How to use it, it's a little bit different. What I recommend is figuring out what DF on the left side means and then using the confidence level on the bottom. So let's talk about what that DF means. DF means degrees of freedom. And how we calculate that is we take the sample size and subtract 1. So in this case, our sample size was 30, so subtract 1. So our degrees of freedom is 29 in this scenario. And then the other thing that we need to know is our confidence level. And our confidence level, we were told in the very beginning here, is that we want a 95% confidence interval. So we want 95%. So using both of these ideas, we can find our critical t value by going to degrees of freedom. We're going to do 30, but we want to subtract 1 from our sample size, so it's 29. And then we want to match on the bottom 95%. So 95% on the bottom, degrees of freedom, that's n minus 1, sample size minus 1. So in this case, 30 minus 1 was 29. So our critical t value is going to be 2.045. And we're going to use this the same way that we use the critical z-score. And we're going to take our point estimate that we had down here and subtract the margin of error. To get our margin of error, we're going to multiply our critical t value we just found and the sampling distribution that we calculated up here in number 3. So in order to do this, we're going to take our critical t value, so we can write it as t asterisk or t sub c for critical, and we want to multiply that by our standard deviation of the sampling distribution, which we have up here is our, let's copy that. That is what we want to multiply. Let's be sure we have a little line over the x bar there for our sample mean. And so that will be equal to our 2.045 that we found just above in number 6 times the 0.0149 for the new standard deviation that we found after dividing by the square root of n. And when we multiply that, we get approximately 0.030. It's good to have some extra decimal places there. Not really necessary for this 0 here, but it's all good. So next, we're going to take this margin of error now. This is now the margin of error. Sometimes you might see that referred to as ME. Got to move this back over so our X bar is still there. So our margin of error, we're going to take the point estimate. To find our confidence interval, we're going to take a point estimate, add and subtract our margin of error. So our point estimate all the way up at the beginning is our sample mean, that 11.3921. We're going to add to it 0.03, and we're going to subtract from it 0.03 as well. So I'm going to take that 11.3921. There's a symbol for plus or minus. And we're going to add and subtract to it 0.030. And that will get us, when we do that, from 11.3621 to 11.4221. And so our final step is to analyze what that means. And so we write this sentence. We start with, we are confident. How confident are we? We're 95% confident because that's our level that we use. That 2.045 came from that 95% confidence level. So we're 95% confident that the interval, and you can read it above, you can retype it on yours, or we can just write it out, from 11.3621 to 11.4221 grams. I like to have that in there, that it's grams, captures the true mean weight of an Oreo. So we'll write down the whole formula that we used, put it all together in one little formula for point estimate, plus or minus, and then how we calculated the margin of error in the box below. So just like we had steps for proportions, we got our information, we said what we were going to do. We're taking 95% confidence interval of a true mean. We checked our conditions, randomness, and that we can use normal. We got to see the word random or have some sort of randomness in our sampling. And then we, for means, if we can see the data and we can see that it's normal, then it's good to go. Otherwise, we need to have the sample size 30 or above. And then we calculated our critical t-value based on our confidence level and the size of our sample. Remember, degrees of freedom is sample size minus 1. We went over to table B to find that value, 29 and the 95%. And then we calculated the margin of error by taking the critical t-value times the standard deviation that we found earlier, and got a margin of error, add, subtract our margin of error to our point estimate to get our interval, and then finally wrapped it up by interpreting what the interval means. And so if we were to examine what Oreos actually say the true weight is, then we can be like, well, we took these 30 and saw that it should be between 11.36 and 11.42, and you're saying it's supposed to be 12.5. Something's wrong here, Oreo or Kraft Company, whoever actually owns Oreos, and then we got an issue. So let's wrap this up on page 10 here, some important ideas. They're going to be very similar to our important ideas for portions, confidence intervals. So we need to check the conditions. We need to check random. We need to see something about a random sample. And then normal. We're either going to see that the population distribution is normal or n is greater than or equal to 30, which is going to be from the CLT telling us that it's normal. The central limit theorem. Next, in order to get this critical t value, remember we need this critical t. A little different than our critical z value. T critical is for means. Critical z value is for proportions. We need degrees of freedom. Which is df is n minus 1. We need the confidence level. And then we'll use table B to figure out that critical t value. And then finally, to calculate our interval, we're going to take the point estimate plus or minus the margin of error. So in this case, it's going to be our x bar plus or minus that critical t value, so t sub c, times the new standard deviation that we found based on our distribution, divided by the square root of n, our sample size. So we found the standard deviation, or we were given the sample standard deviation, and then we divided by square root of n, and then we did this multiplication in our problem earlier. So this is to actually calculate a mean confidence interval. So we'll practice this, application 7.5, we'll put all this together. Again, it's very similar, just find the conditions, random, normal, make sure those are good. And then we go, instead of z-score, we go to t, using degrees of freedom, so that's slightly new, but it's just subtract by 1. Use table B to find that. And then we have our sample mean. Let's draw a line above that. Sample mean, plus or minus that critical t value, multiplied by our new standard deviation. Add and subtract, get a confidence interval, and then summarize what it means, interpret what it means, just like number 9 here on the previous page. Ask some questions, practice, try it. Probably have Math Excel as well, and good luck.